So this is the Studio NPVS 2.1 Life of Mine Scheduling. So we will be going through this particular webinar just over the course of the next half an hour. We do recommend that you remain until the end of the webinar. So my name is Sophie Mellor. I am a consultant mining engineer for Datamine, and I am a certified quarry manager. So I have about 7 years experience as a mining engineer, and I will be taking you through this webinar over the next couple of minutes. So the area in which we are operating within in the Datamine structure is the planning area. So we will be mentioning Studio NPVS, that's the primary topic of today's webinar, but there will also be a couple of mentions of Studio OP as we're going through. We do have a fair array of products going through production, laboratories and sustainability, as well as our original planning topic. So the content of this webinar will cover geological modelling, economic modelling, nested pits, practical pushbacks and an optimised schedule. Hello everyone and welcome to the Southwork project. This particular project is a Studio NPVS project that I will be using to demonstrate how to build up a long-term mine plan schedule. So the first thing we did to generate this project is we imported a block model. So as you can see, this block model is called south.dm. It's not reblocked nor rotated. XYZs are 10, 10, and 10. Our field assignments are density, rock type, volume percentage, geotech, AU and CU grades, and resource category. Our block model contains both ore and waste, and our slope ID regions are weathered, fresh_N for north, fresh_C for central, and fresh_S for south. Our rock type stats are trans, fresh, and waste. In terms of the economic model, it is a cost model. Prices are given by formulas, and material is defined as ore using the parcel revenue exceeds rehabilitation cost cutoff test. The mining cost per mass unit is given by a formula. Trans ore mining cap is 1.125, also has a mill associated, so that cost is given by a formula. AU and CU recoveries are also given by formulas, and the CU has an additional downstream processing cost. The fresh ore also has a mining cap of 1.125. Process is mill, and process costs are given by formulas, with AU and CU also given by formulas for their recoveries, and additional downstream processing cost of $280 per tonne. Waste has a mining cost of 1, and adjustments are given in terms of a reference bench of 10. Below is $0.015 per tonne per bench, and above is $0.01 per tonne per bench. So the ultimate pit has also been generated for us. So I'll give you an example of the settings. We've got an annual discounting rate of 10% and an average ore output rate of 6 million tonnes. We're using pseudo-flow algorithms to generate Lurch-Grossman phases. We're using price factors to generate the phases with increments of 1 up to a factor of 100%. Our slopes are imported 3D slope regions. Weathered has a slope of 40. Fresh has a slope of 45 in the north region, 48 in the central region, and 50 in the southern region. Our pit limits are given in terms of south pit limits, and we are also generating a final pit with a minimum bottom width of 30 meters. That's for safety reasons. So I'll give you a quick overview on what this looks like in terms of our 3D window. So as you can see, we have an ultimate pit limit shown below. We also have pushbacks, and you can see that there are manual pushbacks added. So the pushback settings, we've got a maximum pushback number of 5, mining width of 30, minimum remnant area is equivalent to 100 surface blocks. Total ore is about 10 million per pushback, but we also do have those manual pushback adjustments that were shown earlier. So if we just have a quick visualization of our pushbacks. You can basically see that the pushbacks conform nicely to the pit limits, and they also do obey the manual limits that have been set for them. Okay, we have actually checked that these pushback limits are acceptable to be used in the real world. So we have done basic scheduler settings for them, but we have also gone to Studio OP and we have entered in and generated a series of pushbacks based on the pushback shells. So we have then come in and re-entered these pushback files as phases for our scheduler. So we've basically got everything we need to begin our scheduling. When you first enter the scheduler settings, you will see that there's two attributes, transmill and fresh mill. So we'll just delete these attributes as we want to set a new attribute to control the consumption rate. So we'll choose rock and we'll set a consumption rate of 10 million tonnes per annum. And we'll set it as a factor of 1 till year 9, and then 0.8 till year 12. So that just means that it is ramping down in its last couple of years. Targets, in this case we will actually add the mill as a target. So our first target will be 500,000 with a minimum of 100,000 and a maximum of 1 million. For year 2, we will have a target of 2.5 million with a minimum of 2 million and a maximum of 3 million. And up to the end year 20, so that will be 5 million, a minimum of 4.8 million and a maximum of 5.2 million. So we will also start pushback 3 after year 2, and we'll start pushback 4 after year 3. That just gives distance between the pushback start dates. For parameters, we will increase our resolution for this project. So we'll bump that up to 4, 4 and 1. If you want more details on these parameters, I won't be going through them in depth, but if you hit F1, it'll give you a quick overview and all the calculations that apply to that particular parameter. So in this parameters setting, we basically have the activities and the search properties that control the search tree. This will just be a quick first pass, so we will only be using a sequential dependency for this particular run, but we will be doing this as an iterative process, so we will come back to these settings and we will improve them depending on our outputs. A quick check of the schedule will indicate that your rock is now really nice and even. We have about 10 million tonnes all the way up to year 9 as requested, and then we just drop down to 0.8 for 10 and 11. So that's fine. Similarly with the mill, we are in the process of ramping up to 5 million tonnes per annum. So first year is about 1 million tonnes, second year is about 3 million tonnes, and by third year we are at 5.2 million. The tonnes per annum are pretty consistent to the mill all the way up until about year 10 and 11. 10 is slightly less than 5 million tonnes, and 11 slightly more. We're almost at 6 million tonnes per annum. Similarly, the rock looks okay in terms of its pushback, but we are getting a little too much rock from pushback 3 starting early, and we still have rock from pushback 3 all the way through to year 11. So we could work on these particular pushbacks so that they are much more even and we have a much better flow of rock from different pushbacks going to the mill. Benches by pushback looks very similar. Ideally, we don't want to mine simply one bench from one pushback a year. We would ideally want slightly more than that. And we don't want gaps where we don't mine from one particular pushback for the entire year either. So we do have some work to do in order to smooth out our schedule. Okay, so I'm pretty happy with my first pass. It's given me some decent numbers that I would like to preserve. So I'm actually going to create a new case study. I'm going to call it Schedule 2. And I'm going to copy the settings over from Schedule 1 to Schedule 2, and then activate Schedule 2. This is just a really clever way to go about building up your schedule because it does allow you to revert back to previous settings if you don't like the current settings that you've just implemented. So I'm going to come in here and I'm going to say I want pushback 3 to start after year 2, but I then want pushback 4 to start after year 4. And I also want pushback 4 to have a max sync rate of 8. So basically here, you can actually limit the speed at which your pushbacks get mined. So a max sync rate of 8 limits the number of benches that you can mine in 1 year for pushback 4 to 8. So you can also adjust the max tonnage, but we will not be using that in this particular example. It does something very, very similar. Okay, so we are also going to demonstrate custom mining orders. So in this case, I want pushback 1 to be followed by pushback 2 with a bench lag of 6. Please note, if you've got 10 meter benches, which we do in this particular example, that equates to a 60-meter lag that you have to mine through pushback 1 before pushback 2 can start. Similarly, I want 2 and 3 to also have a 3-bench lag. So we will just run this iteration. I'm just going to take a quick section to highlight this particular parameter here. So for your optimization output, you quite often get this certain number of blocks. Make sure that you have the maximum number of blocks required coming through for your iterations. So we do in this case, so it's all good. But yeah, just keep an eye on that particular number, and if it starts to drop, maybe change your parameters because you are losing blocks from your simulations. So as you can see, we have actually improved our years 1, 2, and 3. We now have basically 1 and 2 pushbacks coming through for the first 3 years. Pushback 3 starts in about year 4. That's fine. And pushback 4 starts in year 5. So we do have probably pushback 4 starting a little early. So I would push that back to maybe year 7. And we do have pushback 3 still being mined in year 11. So that's just something that I would have a quick note of. Similarly, we've got 1 bench of pushback 4 being mined in year 6. And we've also got 1 bench of pushback 3 being mined in year 10. So those are the sorts of things I would have a quick look at and try to improve for my next iteration. You can also see this in terms of the number of benches being mined. So there is that year 10, 1 bench from pushback 3. And there is year 6, 1 bench from pushback 4. So we'll try another iteration to try to smooth out this schedule once more. Okay, for this next iteration, I'm just going to create a new case study. I'm just going to copy the settings from the previous example. And I'm going to activate schedule 3. So we saw previously that pushback 4 was actually starting a little early. So I might push back both pushback 3 and pushback 4 to 4 and 5. But I will keep the max sync rate just to moderate the speed at which we mine pushback 4. In terms of dependencies, I think I'll bump the bench lag up to 10 and 6. And I'll give this one a run. So in this case, our mill has come up to exceeding the amount of tons scheduled to it by year 2. So it's comfortably at the 5 million tonne per annum at year 2. Our rock by pushback also looks far better. You can see the very clear delineation between each of the different pushbacks, and all the pushbacks tend to have enough material that they can be effectively mined one after the other. Benches by pushback also looks pretty good. There is one bench here still at year 10, but that is actually acceptable. So that's pushback 3 at year 10 is the only single bench that's being mined in this entire system. So yeah, I am actually quite happy with this schedule now, and that is an example of how you use an iterative process to gradually refine your schedule till it is at a stage where you are happy with it. If you would like to export your results, we can go into visualize and have a quick look at the scheduler period pits. This will basically take you through each of the year by year extraction sequence. So if you're happy with what you're viewing in terms of the mining sequence, you can then go to data, model, and you can make a pit limited model with the fields, economic fields, ultimate pit, optimum extraction sequence, pushback, optimum extraction sequence, and scheduler optimum extraction sequence. So we'll say yes. And then when you open your pit limited model, if you scroll across, it now gives you your scheduler sequence. It also gives you scheduler years, days, the pushback pit that your block comes from, and the pushback sequence. So yeah, it does give you a whole host of data that can be then entered into Studio OP if you would like to go for a more in-depth manual schedule.